right, so in Unit 2, this is 2.6, describing quantitative data, numerically day 2. And so as we're following along, this is going to complete our Unit 2 notes, and so we'll be getting ready for our review and our test. So our goal today is to be able to compare graphical representations for multiple sets of quantitative data and also do comparing summary statistics for multiple sets of quantitative data. We're also going to be looking at how do we identify outliers using a rule and not just visually. So we'll kind of wrap up the unit here. So 2.6 here, it says, are any of the observations in this data set outliers? Well, looking at it, I would maybe identify this one here, and maybe this one, and even this one's getting pretty far away from what we're kind of seeing the trend is as we go over to this distance. But we need an impartial way to tell this. We need to make sure that we're not just saying, well, it looks like an outlier. So statisticians came up with something called the 1.5 IQR rule. This is something we need to have memorized and be able to describe. In all the free response questions I've read since 1997, about 20-25% of them have a free response question that addresses outliers like this. So the way that we use the 1.5 IQR rule, it says if an observation is an outlier, an observation is an outlier if it is more than 1.5 IQRs above quartile 3 or less than 1.5 the IQR below quartile 1. In other words, 1.5 box lengths outside the box on either side. So if we're writing that as a formula, we're going to say this is taking quartile 3 plus 1.5 IQRs, and this is going to give us the upper bound. So anything above this value will be an upper outlier. And then the other way to find the lower bound, we're going to take quartile 1 and subtract 1.5 IQRs, and this will identify the lower bound for us. So if we want to identify this using the 1.5 IQR rule to see is 5, 6, and 8 actually the outliers, or maybe it's just one or all of them, we're not sure. So what we're going to do is we're going to first find the IQR. So in order to find the IQR, we need quartile 3 minus quartile 1. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 observations. And so when I divide that by 2, 19 divided by 2 is 9.5. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and so here's our 10th observation. So in between here, our median is going to be that 1.5 here. Okay, so then in between, now I have 9 observations here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I should have actually I did that wrong. This is my middle observation because that should be the 10th observation here. So now I should have the 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 1, 2, 3, 4, 5, 6, 7, 8, 9 on the other side. Sorry about that. We didn't need to split it in half. So here's our median. And now on the 9th side, if I take 9 divided by 2, I get the 4.5. And so our 5th observation is going to be our quartile 3 and our quartile 1. So 1, 2, 3, 4, 5. Okay, so there's our 4 on this side, 4 on that side. And 1, 2, 3, 4, 5. Here's our 1, 2, 3, 4 on that side. So here's our quartile 1. Here's our quartile 3. So taking quartile 3, which is 3, minus quartile 1, which is 1, we have an IQR of 2. To do the 1.5 IQR rule, now we want to identify this upper and lower boundary for outliers. So our upper, we're going to take quartile 3 plus 1.5 IQRs. So quartile 3 we have as 3 plus 1.5 times 2. And so this will give us our upper boundary. For the lower boundary, we're going to do quartile 1 minus 1.5 IQRs. And so our lower quartile is 1 minus 1.5 times our IQR of 2, and this will give us our lower boundary. So if I take 3 plus 1.5 times 2, we get 6 as our upper boundary. So anything above 6 is an outlier. So this tells us 8 is an outlier. And then when we do this one, 1 minus 1.5 times 2, we get negative 2. And so there are no lower outliers. So while this is an impartial way to identify the outliers using the 1.5 IQR rule, the reason that it's 1.5 is because statisticians said if we went 2, we weren't identifying enough IQ or outliers, and if we went 1, we were identifying too many as outliers. So they landed on the middle of 1.5. So while this is an impartial, accepted way to identify outliers, it still has some human influence on it to identify them, but it is largely accepted. This is that rule that we want to make sure that we know. So when we're measuring data for symmetric data, we won't use the IQR or our medians or our range. When we have symmetric data, we're going to use something called the standard deviation. It is not resistant to outliers, so that's why we use it with symmetric and no outliers when we have this type of data. This is going to be defined as the typical distance from the mean, which is why we use it with our symmetrical data. So this is how we would want to do this by finding it by hand. And so we would want to first find the average of all of our data sets. And so that's this part here. Then we're going to find the deviations from the mean. And so that's where this is the standard deviation. So deviation is how far something deviates from that average. And so we're going to take our first observation minus the mean, our second observation minus the mean. And this will tell us how far are we off from the average. If we get a negative number, we know it's below the mean. If we get a positive number, we know it's above the mean. And then what we're going to do is take all those values and square them. Okay, by squaring them, it takes our negatives and makes them positive and gives us an overall average here, quantity. And so then when we divide, now we have the standardized value and we square root to go back to the typical not squared deviation. And so after we've then squared each observation, making it positive, added those all up, divided by 1 less than the observations. So this is going to give us that standard deviation. The square root takes us back to a positive number. We've squared it to make it all positive. We square root it to keep it a distance. And so we can do this by hand, but I'll also show you how to do it on your calculator. So when we say another measurement here, if we get to step 5 here before we take the standard deviation by square rooting, we can look at something called the variance. And so the variance is denoted by our S sub x squared. And so variance is that squared standard deviation. And once we square root, this is our standard deviation. And so in our example, it says a random sample of 5 students were asked how many minutes they spent doing homework the previous night. Here are their responses. Calculate and interpret the standard deviation. And so what we would be doing is we would take the first, find the average. So I'm going to add these all up and divide by 5. So I'm going to take 0 plus 25 plus 30 plus 60 plus 90 and divide by 5. And I get an average of 41. So that's my first step. Second step is I'm going to find the difference, 0 minus 41. And then I'm going to find 25 minus 41. And then I'm going to take 30 minus 41. and 60 minus 41, and finally 90 minus 41. Okay, so I'm following these steps here. I've now found the average and I found all the deviations. So now I'm going to square each one of those. So I'm going to take negative 41 squared, and I do want to square that negative. And then I'm going to take negative 16 and square it. And negative 11 and square it. And 19 and square it. And 49 and square it. All right, my next step is to then find the sum of all those squared deviations there. Okay, so now I'm going to take 1681 plus 256 plus 121 plus 361 plus 2401, and we get 4,820. My next step is I'm going to divide by one less than the observations. So now I'm going to take that number and divide by 5 minus 1. So 4,820 divided by 4. And I get 1,205. So this is going to be our variance because we haven't taken the square root yet. When we take the square root of that number, we get 34.7. And that's our standard deviation. Which is what we were looking for. So we could say the standard deviation S sub x equals 34.7. And if we wanted to interpret that, we would say the typical distance, which is why it's positive, from the mean, which was 41 minutes, is 34.7 minutes. So while the typical student spent 41 minutes on their homework, there was a large variation from that mean because it could vary on either side by 35 minutes, which almost gets us down to 0, and on the other side over an hour. And so as we look at that, it kind of defines our data that we have here, where we do have one student that did all their homework, hopefully during the day, and another student that spent over an hour and a half on their homework, or at an hour and a half on their homework. So this is a tedious way of calculating it, but it's always going to work. And we're just breaking down that formula into our parts. Find the mean, find the difference, square them, sum them, divide by that quantity, square root. So it's a process, and it takes a little bit for us to do by hand, and that was only for a small data set of 5. So let me show you how to do this on your calculator. When we get to our calculator here, let me find it. We're going to put that same data into our calculator list. And then we're going to be able to find a lot of data about this list here. All right, so let me get that on our screen. All right, so I'm going to clear this out here, and I'm going to go to my stat, edit my list, and I want to put in 0, 25, 30, 60, and 90, so I have that data ready for me. And then I'm going to go back to stat, and then I want it to calculate something for me. So I'm going to go over to calculate, and I want to calculate, I have one variable, and I want stats about that one variable, so I'm going to select option 1. All my data was stored in list 1. Each occurs once, so I don't need to change the frequency list. It's not associated with another value. And calculate. So look at the data that it gives us. It gives us the 41 that we calculated by hand. And then here's where it gives us that standard deviation that it also calculated by hand. Then we have the population. So if this was a full every student, we wouldn't be dividing by n-1, we'd be dividing by n at that point. But typically we don't have access to the entire population, so we divide by the n-1, which adjusts for ours being a sample. So it gives a little bit more room here. But if you continue, I also have more information. I have 0, I have, as the minimum, I have our 12.5 quartile 1, median is 30, quartile 3 is 75, and the max is 90. So it's calculating our 5-number summary here for us as well. So as we move into more lessons about describing our data, one variable stats is going to be really important because it'll give us that quick snapshot of our data. If it is symmetric, we're going to be wanting to use the mean and standard deviation. If it is not symmetric, so skewed or has outliers, we'll want to be using our 5-number summary along with the interquartile range. And so we're able to calculate the 34.7 here, once again on our calculator. So the factors that we should kind of be keeping in mind as we're choosing summary statistics, and so that is our center and our spread. And so as we're considering our center and spread, we want to keep in mind what the shape is and if there are any outliers. And so if you think about our socks, the way that we describe it, shape and outliers comes before center and spread. And so we have two kind of differences here. If the shape is symmetric with no outliers, then the center and spread we want to pick are mean and standard deviation. If we have skew in our graph or we have outliers, then the center we want to pick is the median because it's not influenced by those outliers or the skew. And then we'd want to pick the IQR as our measure of spread because that'll tell us how the middle 50% are influenced by that data. And so this will kind of wrap up our quantitative data looking at describing it numerically. If you have any questions, let me know, and I hope you have a good day.